Now let us consider this problem. A symmetric die is thrown 720 times. Use Chebyshev's inequality to find the probability that the number of sixes lies between 100 and 140. Listen, actually for this you can even try to compute the probability value directly, but the question it is specified that you should use Chebyshev's inequality. So let us basically identify the variable. The variable x is the number of sixes. What is the experiment? You are throwing a die, a symmetric die, an unbiased die is thrown, and x represents number of success. So p represents the probability of getting a success. What is a success here? It is equal to probability that the outcome is 6 when a die is thrown. There are 6 outcomes, out of which only one outcome is 6. Okay, 1 by 6 is the probability. So even though the die casting experiment has 6 possible outcomes, ultimately you are going to consider only whether you are getting a 6 or not, success or not. So in this case your x is assumes only 2 values, success or failure. So it's your variable. So your x follows binomial distribution. Okay. Since there are only 2 outcomes in the random experiment, your x assumes binomial distribution. Okay. So now you know the p-value. What is n? How many times you are throwing a die? An experiment is repeated 720 times. So in a binomial distribution, you know expectation of x is n into p. 720 into 1 by 6, that is 120. And in a binomial distribution, you know variance of x is n into p into q, that is n into p into 1 minus p. 720 into 1 by 6 into 1 minus 1 by 6. Okay, 720 into 1 by 6 into 5 by 6. So you get 100, right? So your mu is equal to 120 and sigma square is equal to 100, which implies sigma is equal to 10. Don't write plus or minus, sigma cannot be negative. Now among the two inequalities, right, which inequality will suit the purpose? You want the probability that x lies between, that is number of sixes lie between 100 and 140. This is what you require, right? Based on your requirement, let us identify, see among these two inequalities, which inequality will suit the purpose. This is talking about greater than or equal to. This is talking about less than. So let us consider this inequality. Okay, this will suit the purpose now. That is how you should select. Okay. Now the second inequality says probability of modulus x minus mu less than k sigma is greater than or equal to 1 minus 1 by k square. That is, it says probability of minus k sigma less than x minus mu less than plus k sigma is greater than or equal to 1 minus 1 by k square. That is probability of, take this mu on either side, mu minus k sigma less than x less than mu plus k sigma is greater than or equal to 1 minus 1 by k square. Okay. What is your mu now? Mu is 120. Minus k is k. You don't know the value of k. Into 10. Let us write it as 10k. Okay. Less than 120 plus 10k is greater than or equal to minus. You can now find the limit for the probability, but the problem is you need the value of k. Okay. So to find the value of k, you come to your requirement. You need 100 here and you need 140 here. And if that is the case, what should be the value of k? You can calculate. Okay. See, 120 minus 10k is 100. Do it. 120 minus 100 is 20 is equal to 10k. So which implies k is equal to 2. If you take here 120 plus 10k should be 140. That is 10k should be 140 minus 120. So k is 20 by 2, 20 by 10 it is 2. So in both the cases k is equal to 2. Right? If there is a change in the value of k, you cannot apply this Chebyshev's inequality. Okay? In this question, k equal to 2 gives these numbers. Only then you can apply Chebyshev's inequality. It has got a lot of restrictions. See, it is giving only a limit value for the probability. It cannot give the exact probability. Chebyshev's inequality cannot give you the exact probability. Okay? Now k is equal to 2. You know. So you can say that probability of, if you put k equal to 2 here, you get probability of 100 less than x less than 140 is greater than or equal to 1 minus 1 by k square, which is 2 square. So probability of 100 less than x less than 140, even though I don't know, I cannot find the exact value, I can say that this probability is greater than or equal to 3 by 4. Okay, so using Chebyshev's inequality, find the probability. That is the question. With Chebyshev's inequality, you cannot find the exact probability, but you can simply say that the probability is greater than 0.75, greater than or equal to 0.75, right? This is the answer. Thank you.